Oh. If you're watching this video not during the live stream, check the description below after a few hours. It will have time codes to skip around in it. So it's going to be about 2 hours. We're going to take about 10 minutes or so, 5 minutes or so to get started. So if you don't want to just sit around and hear me talk, I mean, that's what this video will be anyway. But yeah, check the notes below for like kind of table of contents of what we're talking about today. All right. Hello, everyone. Good morning, Internet, says Unexpected Maker. Hello, Hugo. Hello, Alvaro. Oh, let me turn off my streams here. Looks like everything's going. Everything's looking good. Hi, Anecdata. Hi, Paul. Hi, Bad Devil. Hi, Gordy. Hi, John. Hi, Norm. Hi, Pavre6. I almost missed you. Very good morning from India. Hi, Ken. Thank you, Jose, for helping me a bit early. Hi, Simon. Hi, James. Hi, Bruce. Hi, Quirky. Hi, Randy. Waiting on my Pico. Yeah, hopefully it's on its way. I'll tell you, I'm waiting for my new processor. I got the motherboard and I'm getting the RAM hopefully today or tomorrow. Gonna upgrade this computer and I'm super excited about it. Gonna have all the cores. Hi, Jim. Good afternoon. Seattle looks pretty good. I haven't actually been outside very much, but the sun was out during lunch. But yeah, I would say it's a bit chilly. The object is deep in the bowels of Discord's stream kit. Dug into it for a while on Wednesday and Thursday, and it comes from the server like that. Oh no. I did try it on Chrome, and it had the same problem. Thank you for looking into it, Hugo. I was also wondering if there's an issue we should find. Hi, TG Techie. Hi, Bad Abby. Yeah, that makes sense. It's interesting that the Hugo came through okay. If you put object in it, maybe it works. Hi from Cornwall. Hi, Andrew. Hi, John. John says, I'm really curious about the PIO for driving Hub 75 LED arrays. I know that there's an example and that Phil B has started looking at it for the Proto Matter stuff. Tim says, I got 3 Picos from Canikit that came last night. The Adafruit order comes Monday. Steve says it's in the teens there. That's too cold. So it's not me objectifying everyone, it's Discord. No, it doesn't work. Good try, TG Techie. Hi, Emmett. How's everyone doing? I was not as productive as I was hoping this week, but I'm kind of hoping to do audio all in one fell swoop. Hi, Mike. What's the weather like in St. Louis? Hi, Simon. Ooh, that's nice. I have 32 gigs of RAM coming as well. And Randy says I'm going to use a Pi 4 to develop with the Pico. Yeah, that's the only way I did. I have a Pi 4 on my desk that I should probably turn off that I was using when I needed to SWD it. Hugo says that's what someone mentioned on Reddit. Hi, Griffin. Do we have anybody watching on non-YouTube? Hi from Thailand. That sounds warm. Hi, Martin. Ooh. Emmett was very productive, but burned my finger with a 1 amp LiPo. Pavre6 got my first Pico. Day before yesterday, I played with it for 24 hours, but it just died last night. Oh no, that sounds surprising to me. That's the first time I've heard somebody of it dying on them. Hi, Matthew. Hi, Johnny. Yeah, Gordy says program to do quadrature encoder without interrupts. Yeah, we're gonna have to look at that. Mike says not too bad here. Sunny, couple inches of snow on the grass. 40. I think we're in the 40s here as well, but we don't have any snow. Hi, Grogard. Hi, Keith E. 26C-ish. It'll warm up when the sun rises. Yeah, that's warm anyway. Hi, David. Thank you for testing Twitch for me. Christian says, I guess I'll say hi too. Hello, looking forward to playing with the PIO soon. Where are the kitties in the kitty cam? We have one kitty on the kitty cam. Vin's not in here. She was all fussy. But Spook's in his bed. Surround your name with brackets does work. Really? That's hilarious. Something's wrong on their end. Alright, it's 2 o'clock. Thank you all for saying hi. Spook's sound asleep in the sun. Johnny got a Pico with the Hackspace magazine today. Dominic says, I'd actually like to start playing with the Pico, but it won't be here until the 12th of March. Who did you order it from? Hi, Mark. Almost missed you. Doesn't look like the bracket trick works for everyone, though. Didn't work for Bruce. Some people are just special, I guess. Maybe it's like different versions of a server. Hi, Generation. I think I said hi to everyone. If I missed you, I'm sorry. Steve says Pimoroni has Picos in stock still. Awesome. All right. Hi, Folknology. Let's get the show on the road, shall we? Let's start with housekeeping here. I think I have the timestamps going. Oh, let me switch to... Hello, everyone. My name is Scott, and I work for Adafruit on CircuitPython. If you don't know what those are, Adafruit is an awesome open source hardware and software company based out of New York. I work remotely for them, so I'm in Seattle, which is on the other side of the USA. It's just after 2 p.m. in the afternoon here. This is the normal time that I stream on the Adafruit channels. We do deep dives, and questions are welcome. They typically go about 2 hours, so about 4 o'clock is when we'll end up finishing up. Like I said, questions are helpful, and I'll take those as they come in. We like to wander. We like to talk about whatever it is and dive deep into the topics that we cover. So Fridays, 2 p.m. Pacific. I'm in Seattle, that's why it's Pacific. Next week is on Friday as well. Occasionally I'll shift it to like Thursdays if that doesn't work out. So Adafruit, open source hardware, open source software. If you want to support me, support them by going to adafruit.com and purchasing some hardware there. They pay me to work on CircuitPython full time. So if you like that, support them, please. If you want to chat with me and a lot of others, get some help with your Picos or whatever boards you're working on, Arduino, CircuitPython, Raspberry Pi, there's folks in the Adafruit Discord server, which you can join by going to the URL adafru.it/discord. Hop in there, chat with us. You'll see there's a number of help with channels there. That's where if you're just getting started, you can get some help. And then there's also a CircuitPython channel, and that's where we do all of our discussion for CircuitPython development. CircuitPython is an open source version of Python based on Micropython that's designed to make it really easy to program small computers called microcontrollers to do basically one thing or a few things. It's not going to be your broad, like run a whole web server and all this stuff with Python. It's much simpler, designed to be more embeddable in different things that you're working on. Last piece of housekeeping, the cat in the picture. This is a cat cam. That's Spook. He is epileptic. He does have seizures from time to time. He's been doing really well on his new med, so I don't expect it to happen. But early on when I was streaming, it did happen. So I just like to say heads up if I'm like on the stream but not paying attention. That's what's going on. I'm just making sure he's okay. And he'll be okay. He's actually, looks like he's dreaming. His paws are going like this. Sleeping in the sun. Okay. So that is it. A couple more hellos. I think. Oh, John says, I had a kitty that had seizures sometimes too. Yeah, it's weird. Especially when you go to the vet and they're like, oh, this is usually just dogs. Hi, Tabletronics. Thanks for hopping in. Hi, Mark. Sorry, I missed you if you said something earlier. On the website, Dominic said, oh, it's a German spot. Yeah, sorry. First question of the day I see here is from David, who said, why did you mention Shenzhen IO in your last stream? And I think that's because he got fully addicted to the game. We were talking about the like low-level assembly nature of PIOs, and Shenzhen IO, if folks haven't seen it, is very much like it as well. Switch to the desktop. So it's a Zachtronics game, who's like a game maker known for doing puzzle stuff. But you can do like little, very simple like state machine sort of assembly stuff, which is totally like PIO. So if you get sucked into video games and you don't want to, don't look it up. Otherwise, it's pretty neat. Although I've seen people doing PIOs, real PIO stuff as well. Mototimo says, any plans for, maybe I should take if I'm going to answer some questions here, let me take some time codes. Oh yeah, and we have one from DCD as well. So any plans for ESP32 wired Ethernet featherwing? Not that I know of. I mean, we already have a Wiznet featherwing, so I would assume that that's enough. And Foamy Guy warns against looking at Factorio as well. Yeah, John says, I'm glad you found meds that work well. Yeah, it's been 5 years since we really have. Yeah, so it's been really good, these last meds that he's been on. Otherwise, he was having them every 2 weeks or so. But it's been a few months at least now, so it's good. Flavio says, hi Scott, I'm Flavio F. You helped me with an MQTT issue the other day, just decided to drop by. Welcome. And Paul says, I have a dog that has seizures too. Meds help once you get them right. 100. Hi Matt, thanks for hopping in. I know it's Saturday morning in Australia. Sorry about that. Do you have any questions before you get going? Johnny asks, does the Wiznet library support TLS? And the answer is, I don't know. David says, I bought three RP2040s and gave 2 of them away. Zero from Twitter is asking, which OS are you using? I'm using Arch Linux with KDE. And then it's set up with a weird skin as well. Moto Timo says no TLS, along with Anecdata says no TLS. So yeah, no TLS on there. Rolf says, can Pico run CircuitPython? Yes, definitely. If you want to run CircuitPython on your Pico, you go to circuitpython.org/downloads. And then you can search Pico. And you can find the Raspberry Pi Pico here. And since I have it pulled up, I'll put it in the chat too. Matt says, I'm curious about how the Pico port is going, but no burning questions. So, yep, Arch Linux. We can talk a bit about that. I can talk about where we're at. state of CircuitPython 2040. So I would say we're a lot of the way through. We have kind of what I would consider the core of CircuitPython. So all the USB stuff works. They use tiny USB in the Pico SDK, so like that kind of just works, which is great. So that means we have mass storage, CDC, HID, MIDI, and then that works. We have bus IO, but bus IO we only have I2C and SPI implemented. I haven't done UART yet. A couple people have done that. David says maybe you should discuss the disk partition of the RP2040. Yeah, we could talk about that a little bit, and also the GPIO 15. So we have that. We have PWMIO, which gives PWM out. Yeah, Twitter account at Adafruit, or my personal one is at Tinute. Let's see. API wise, I was gonna do UART, and so we have RP2040 for the PIO. What's missing there is we only have write implemented right now. We can't read from it. And the reason that is because I was focused on supporting NeoPixel. So we have NeoPixel. It works with PIO under the hood. So you don't have to like instantiate the PIO yourself if you want NeoPixels. It works like any other NeoPixel. Yeah, so there's work to do on PIO to get reading from it. And then there's a big question mark also about there's also some thoughts about like how to do async like buffers to and from a PIO that I've been thinking a lot about. But my current focus is actually on all the audio stuff. So I want to do audio PWM, so playback audio to the PWM on the RP2040. I want to do I2S out as well, which will give you better quality. And then lastly, I just looked at it, and PDM in, which is the microphone that we have on the Circuit Playground, looks very easy to do with a PIO. So I think I'm actually just going to try to knock out all those three. And I was originally just going to do audio PWM, but I kind of like grew what I wanted to do because a lot of the code is shared, and I wanted to unify that there. I wanted to like centralize it from the get-go. Okay, let me read back. I know I said a lot. David, we'll get to you in just a bit. That does remind me. I think Matt mentioned this. So Matt runs the Melbourne Micropython meetup, and they've been streaming their meeting. So if you want to see like straight from the horse's mouth, straight from Damien's mouth about where Micropython is, I recommend doing that. They do it once a month. It's late at night for me, but everyone's in different time zones. And Matt did ask whether we'd be able to do IRQ support from the PIOs. I think there's one thing we could do in CircuitPython is we can simply have you be able to read the state of the IRQ. There is some trickiness about like allocating IRQs between different programs in a PIO, because there are only 4 and they can address any of the 4. So there's got to be some way to like allocate them, which is a little weird. So yeah, there's definitely work there to do, but a lot of what we do when we design APIs is like start from the very minimum with what we know we need, which is what I did for PIO for NeoPixel, and then we'll like add stuff to it as we find that we need it. For example, like for PDM in, I'd love to be able to test it with the RP2 PIO interface, and therefore I would be able to need to read some bits. And so like I'll probably just add that. So yeah, that's kind of like the PIO stuff. Hi, Mbeck. Okay, we've got questions. And if anybody else has a question and they can't stay the whole time, just let me know and I'll try to prioritize it. Hugo asks, how do you come to choose Arch? I really like rolling release distributions, meaning that there's no like, here's the release every 2 years or every 6 months. There's this just like, we update things as updates come. I was on Gen 2 for a long time, but compiling everything gets old. And also the Gen 2 community for a while, like kind of, I think from what I could tell, lost its way, and like the wiki wasn't as up to date as it was. And I think Arch in a lot of ways like kind of supplanted Gen 2, and that like we don't need to recompile everything, but we have a really good wiki on how to set everything up. And I like the rolling release stuff. I like to know what the latest and greatest is. Yes. So, okay, yeah, and Matt's going to post the recordings of the older Micropython meetups if you missed it. Let me just address this question here from Gareth, who said, how to smooth library porting to and from Micropython. I think, so we do have Adafruit Blinka, which was originally actually designed to put the CircuitPython APIs on top of Micropython. So if you really do want to do that, I recommend it. But honestly, I think you should just use CircuitPython. There's not a whole lot that I know of that you can do in Micropython that you can't do in CircuitPython. People will say CircuitPython doesn't have interrupts, but all the things, I haven't found somebody who can't do something they need to do with interrupts using the tools that we've given them in CircuitPython, which has kind of been our model. So I would say, like, obviously I'm biased, right? Like I work on CircuitPython, but CircuitPython has very strong baseline APIs to build on top of. And so I would recommend starting there. Pavre6 says, where'd my notes go? Sorry, I'm getting backlogged, but we'll go through them. Unable to create some images. Oh, because I don't need the emoji in there. Thank you very much. How feasible is it to replace and upgrade the flash chip on the Pico? I think it'd be pretty hard because the chip is really small. Like it's very tiny. It's not like the flash chip is this chip here, and it's not a large one. You're gonna definitely need a hot air gun. And if you have a hot air gun, you could probably do it. But software wise, you'll need to change the size that everything is. But yeah. One reason I like interrupts. Can't stop an ongoing network fetch via button presses. Yeah, this is what I say about networking. Networking is the reason that we really have to deal with that. It's a pain. Flavio asks, and I'll just roll through these. Lots of good questions. Let's see. Flavio says, have you ever talked about OTA on the CircuitPython based deployment? So we talked about it briefly in the hack chat on Wednesday. Basically for ESP32S2, we set aside space for a second copy of CircuitPython that you can use to switch between the two. And there is an API for writing to it and switching to it that MicroDev added. So try it. But again, it's open source software and it comes with no warranty. So if you are expecting to deploy it in a lot of places, you are responsible for making sure it does what you need. Yeah, at the end of the day, it's on you. Okay. So Rolf says, what makes the Pico better than other boards? And here's where I'll say, I don't think the Pico is a very good dev board. The reason that it's very popular right now is that it's the first and only way right now to get an RP2040. The RP2040 is really, really interesting. But the Pico as a dev board, I think, is not great. And I'll tell you why. I shouldn't just criticize it without backing it up. So let me switch here. So I don't have the overhead set up today. So here's the dev board. One criticism I have is that there's no pin labels on the top. So the top doesn't tell you what pin is what. And if you put it on a breadboard, that's going to be a huge pain. Now, some people are like, oh, well, I just put this side up. But the problem is that there's a button here. And that button is the boot select button. So if you solder it down this way, you can't get access to the button. Secondly, if you want to restart the board, you have to unplug it and plug it back in because there's no reset button. So I also think that's a fail. So honestly, I don't think this is a great dev board, but the chip is really, really cool. And one thing to say about this dev board is that it is very inexpensive. So it's very cool that it's $4 a pop. And the castellations are cool too. So I think there's room for improvement. But I'm one of the few people that has like a prototype RP2040 feather, which is this one. So like here's something that Adafruit has designed, but we just simply don't have the chips yet. It's got a USB Type-C. It's got a battery charger like all the other feathers. There are labels of all the pins on there. Yeah, so I think I'm biased, but I think the RP2040 chip is really cool, and it's worth getting a Pico to play with it early. But once the chips become available, I think you're going to find better dev boards than the Pico itself. Okay. So Ryan asked, will PWM capture be supported? Yes, eventually. So that's the Pulse IO module. That is something I want to add, but it's not super high on my list. So if you'd like to take a stab at it, that would be awesome. But I'm trying to do audio, and then I need to do UART before I get to Pulse IO. Quirky says after the Gentoo wiki loss, it hasn't recovered very well. So they actually lost the data. That's unfortunate. Really like Arch on Raspberry Pis. Yeah, I just run Raspbian on there. Generation says Pentoo versus Arch, for your opinion, which one is more secured? I don't know. I'm not a great security person. There's better folks to ask that of. In fact, I realized because I do open source work at home, like I don't even have my screen doesn't lock. Like I don't need to type my password in. There's very little reason to worry about that. Randy asked, is CircuitPython going to support the dual cores of the Pico? I think we should. I think I talked about this last week, so if you haven't watched last week, at least look in the time codes for there. But the gist is that I'm really thinking about treating the second core as a run something bare metal assembly or short compiled C code on it instead of just running more Python. So yeah. Matt says interrupts and solid async IO. Yeah. So Mbeck says we have async IO turned on, but it's based on the older version. We do want to update to Micropython. That's one of the reasons. But concurrency is really hard. I'd love to know what you use interrupts for, because you may not need them in CircuitPython. Let's see. Oh yeah, so yeah, power on LED. That's a good point too. Folknology pointed out on Discord, for Pico, you can always run Micropython on Core 1 and CircuitPython on Core 2. I'd love to see somebody do that. Micropython assumes it can use the second core, though. And you have to worry about like where you place it in Flash as well. M. Beck asks, will there be a start with CircuitPython on the Pico book? So let me let you in on a little secret here. If you go to Learn, we have a guide. I don't think it's on new guides for some reason, but we have this Get Started Raspberry Pi Pico. And here's a little secret. We actually have in the works CircuitPython examples of the stuff that's in the Micropython Pico book. So that will get you going. It's just not quite finished with review. So keep an eye on this guide. Next week, hopefully it'll go out. But these are the examples that are from that book, and we had the Python version of them. So it's coming. I don't think we'll never print it out as a book, but at least we'll have the comparison of how the two work. Yeah, Christian points out the RP2040 could dedicate a whole core to networking. Thanks, Matt. You may be gone by the time I read that. Tabletronic says the Pico is like a breakout board. Yep. Right, Christian says it's a little surprising they could fit a buck boost converter into the budget but not an extra button. Yeah. It's priorities. Like, clearly they want it to be embedded in other stuff too. So, who knows what their design constraints were. Oh no. Feel better, Mark, and get some sleep. I know it's late for you. Daniel says, could you tell us, I'll take a time code. Hold on. We can talk about this briefly too. It is something I've covered before, but it doesn't hurt to say again. We'll see how long I can ramble. Daniel says, could you tell us something about CircuitPython versus Micropython? Yeah, so CircuitPython is based on Micropython. I was hired in 2016 to start working on Micropython for Adafruit. But as I started to look at it, one thing I noticed was there was no consistent hardware API across all of the ports. As I was like adding a new port, I was adding for the SAMD, and it wasn't clear. There was no one central place documented of what the standard API was. And that was really, really important to me because I knew Adafruit was going to do the same play or model that they had for Arduino, which is like, now we're going to make drivers and sample code for all of the products that we sell on this foundation. And I knew that because of that, we needed to have a solid hardware API at the bottom of it. So that was like one of the main reasons that we kind of like moved away from CircuitPython. So generally what you'll find is that CircuitPython is more consistent across ports. A lot of our work does focus on the like, how do you get going really quickly stuff. So we don't have as advanced APIs as Micropython does. That doesn't mean that we can't add them if people want them. It just means that like folks paid by Adafruit to work on CircuitPython will only do reviews. Like I'll review that stuff, but I won't work on it myself. So yeah, I recommend CircuitPython. One of the selling points I say about CircuitPython for the Pico in particular is that the Micropython version doesn't do mass storage, so you have to use it. You have to use it with Thonny, which I think some people like it, but I like the philosophy of like you can use whatever editor you want, and some editors are more handholdy than others. And so the way the CircuitPython does is you drag and drop it on your Pico just like Micropython, but then it shows up as a CircuitPy drive with your code on it, which makes it much easier to get started, much quicker as well. So if you could try both, and that's what I recommend. But yeah. As Patrick says, maybe we can record this answer, Micropython versus CircuitPython, plays it as an outro. Bravo Delta says, I firmly believe CircuitPython wouldn't be as great as it is without me. Thank you. I'm glad you think it's good. I've definitely put a lot of my time into it and my software background as well. Yeah. Sai says, at my previous job, the head of IT used to open a random web browser tab that is offensive to warn people to lock their laptops when leaving it unattended. Yeah, luckily the cats haven't figured that out yet. Hi, Nicholas. Greetings from Chile. Hi, Chris. Okay, I see this question in a couple spots, so let me answer it. And DCD does have a question I should answer too here. So, what is your guess how far the PIOs can be pushed quadrature encoder-wise for CircuitPython? You know, I haven't looked at it. The tricky thing is, the tricky thing with quadrature encoders is, like, the PIOs don't do any sort of state machine. So besides reading the values on the quadrature encoder, I'm not sure. I don't think I've seen an example to do it yet. So I'm not actually sure whether the PIO is the right way to go about it or not. In CircuitPython for ports without PIO, we'll just do interrupts. We do interrupts on pin change of the 2 pins. And maybe we can use the PIO to do that as well. Emmett says, GitHub changed my picture. That's unfortunate. Tim moved away from Micropython. Paul says, so lesson number 1 for the night, don't try to make tea, load a dishwasher, and watch a deep dive at the same time. Just dropped a sharp knife on my finger, is blunt side luckily. Ooh, that very lucky. Sai says Thani is a bit weird to use. It has some good things, like it makes sure it saves your files, I think, to the PC as well. Pikachu922 says, Arduino on the Pico when? That's a question for Arduino. I have no inside knowledge. And I would say, really, you should try CircuitPython. It's easier. It's easier and it's faster to iterate too. Let's see. Did I miss anything? Yeah, and Paul was suspecting that Arduino will launch software support when they launch their board. And Beck asks, do you see the RP2040 Pico and CircuitPython overtaking Arduino due to Python being so much easier to code for beginners and otherwise? I mean, that's a bit of a loaded question. Certainly, like, we are trying to make something that's easier than Arduino, but Arduino has its place. Like, there's definitely things that you can do with having a compiler that you simply can't do in CircuitPython. So I think it's more about, like, pushing Arduino to improve stuff, and MicroPython as well, right? Like, we see what each other is doing and we see the innovations that are happening and push that. So I want people to try CircuitPython. I do think it's a better experience than Arduino. But that doesn't mean that, like, Arduino is not going to exist. Hi, Blitz City. Thanks for hopping in. Toddbot says, I'm having a hard time installing Linux on my Pico, even Arch. Yeah, you're not going to be able to do that. And I feel bad for Raspberry Pi having such a strong brand associated with Linux that I'm sure they're getting lots of questions like that. Gareth says, Arduino was a game changer a decade ago when getting your toolchain running took a week. Now it's getting a bit old. Yeah, I think the fact that Micropython and CircuitPython have tool chains built in that you don't have to install is a huge deal, and quite surprising why the Pico Micropython doesn't allow you to just edit the file on the drive sorts of stuff. It requires the Thonny install or R shell, which is weird to me. Not even Alpine. Yeah, well, so the Pico doesn't have a memory map unit, so I don't know if there's Linux without that. My understanding is that you need it for Linux so that you can page in memory. Oh, what's the wrong spot? Oh, and let's see what Mbek is asking here. I often get old print statements from infinite loops still printing in the Muse serial output after saving and my code restarting. Is that due to a big buffer somewhere still pushing out text? That sounds like a bug to me. If you see it restart, I would expect it to be different. Sometimes what can happen is you can have partial updates of the code.py depending on how your host OS writes stuff out, which could also cause the problem. Yeah. Kristen says, probably not Linux, but there will be a lot of C64 clones and the like, I bet. I want to make CircuitPython a C64 clone. We talked about this before, but I think it would be really cool to use CircuitPython like a C64, where you're just in one screen and you're editing on it and stuff. I actually had the basic Python. If you saw it last week or the week before, I did this super quick demo of editing Python like it was basic. If you can see the animation here, but it does the prompt and then so yeah, it's 30 lines of Python, but you're editing Python code like it's basic, which is a bit weird, but I think kind of cool. Let's see. Hugo says Micropython versus CircuitPython. Try it yourself and take the Pepsi/Python challenge. Oh yeah, somebody asked about QSPI. So the Love Factory. Someone is going to get Doom running on the Pico. Where did this go here? Is CircuitPython doing quad SPI or Q to Flash, or is it just SPI? I think right now it's just SPI, and thank you for reminding me. That's actually something I need to work on sooner rather than later. CircuitPython Pico or RP2040 right now is just assuming that the Flash works in the way that it's set up, but that's not actually going to be true. We actually need to be able to configure how to talk to the Flash. And so that's something I have to do. So right now I think it is just SPI, but I'd like to move it to QSPI. But in order to do that, we need to be able to configure which Flash chip you're talking to. Yeah, the PIO ASM stuff is definitely not for beginners. I agree with that. But it's important to note that we are using PIO to do the things that you want to do without you needing to know it's PIO as well. Tobbot says Arduino is great because it doesn't create a floor for efficiency. You can drop down to bare C SDKs or even assembly. That is not possible in CircuitPython until maybe we get the ability to load binary modules. So Micropython does have a way to inject assembly into it. We don't currently have it, and we might have it enabled. I'm not sure. But I would argue that you're arguing there's no floor because you're already in the basement. It is possible to drop down into C, but that it's more work to go down a floor, for sure. Kristen says, "Oh, that's awesome." Yeah, I really want to get CircuitPython running bare metal on the Raspberry Pi. I want to get it running bare metal on the Raspberry Pi so that you can do like this C64 style CircuitPython on a Raspberry Pi 400 specifically. Keep trying to move forwards with CircuitPython, but fall back into Arduino IDE when I want to use some other chip. I have a tiny Pico and a Feather S2 project underway, and I will soon use Python. Let me just say that the fact that CircuitPython works the same across boards is actually really, really powerful. Like, I've had to point people like, we don't need a Pico book because all of these things besides PIO are the same. And I don't think people fully appreciate that yet. Okay. We got a question from Jackwith. Says, did you implement peek and poke from C64? No, I didn't. We've thought some about how we would have memory IO, allowing you to like peek and poke registers of a certain range. But the example I'm doing is actually just running in CPython. Davey asks, can CircuitPython take advantage of Sparkfun's proposed larger flash part? Not in its current form, but my hope is to get all the flash stuff refactored so that by the time the boards are actually available, we can. And the way that it will do that is we've allocated a megabyte at the start of Flash for CircuitPython, and then the remaining megabytes, however many they are, will just show up in your CircuitPy drive. And in fact, I think we're planning on putting a 4 megabyte one on the Feather, although no promises until it's actually released. Ryan asks, will Firmata work on this board? I think Firmata is based on Arduino, so once there's Arduino support, it will. But I would say if you, like, my understanding is that Firmata gives you Python on your host to talk to the board. I would encourage you to look at Micropython or CircuitPython as a way to actually do it better because it runs independently. Gareth says, actually, now you've wrapped it up, it might be a perfect educational vehicle for assembly. 100%. That's why I'm thinking like PIO assembly to start and then Cortex M0 assembly after that. Hi, Paul. Ooh. Let me answer lots of good questions. So Flavio says, just to follow up on the OTA question, what I meant was the support for changing files like code.py on the mass storage and not CircuitPython itself. Would that still be considered OTA? I think so. There's a current PR that allows you to switch the next file that CircuitPython runs, and I think that's what you need, because that PR also allows you to say, like, run this file, on success do this, but if it fails, like if it throws an exception, run this other file or do something else, which I think is like the primitive that you need to like do OTA of Python. Axe Patrick W says, the ability to use CircuitPython libraries across boards is huge. In Micropython, many libraries are port specific. Yeah. Mototimo says, CircuitPython is common with the exception of the ESP32 SPI Ethernet support. There are other things that only work on ESP32 Wi-Fi. Right now, not Wiznet 5K. Yeah, that's because the first round of our socket networking stuff was not very socket compatible. So the goal is, like, as we get through it, like, we'll be able to like have real sockets, and then like it'll work. Then the libraries that build on sockets will work in CPython and ESP32S2 Wi-Fi, and then hopefully Wiznet and ESP32 SPI at some point as well. David says, how would you control a low power state entry without wait for event or wait for interrupt? So CircuitPython has higher level primitives for low power states. We've just added all these APIs for the ESP32S2. And the way that it works is that CircuitPython will basically do wait for interrupt automatically when it's asleep. So you'll just get that for free. We don't do any cross-core stuff yet, so we won't do wait for event. But basically the philosophy is we'll do it for you. So that, like, time.sleep is a light sleep. We also now have, I'm already forgetting the name of it. So on readthedocs, you can see all of the APIs. And we have the ability to light sleep until an event occurs, which we call alarms. So alarms and sleep is where you want to look. And we have the ability to persist memory. We have light sleep until alarms. So you give it any number of alarms, and then when it wakes up, it gives you the alarm back that woke you up. And then if you want to do deep sleep, we have this exit and deep sleep until alarms. And the way that works is you give it a list of alarms as well, but it actually never returns. It shuts everything off. It validates that you can wake up from deep sleep from those alarms, but then it will restart your code and set the alarm that woke you up as alarm.wakeAlarm. So you don't need the assembly versions. We've got an API for doing sleep state stuff. And under the hood, we try to get the sleep state as low as we can based on what you want to do. Christian says there was a guy who made Lisp REPL on bare metal Raspberry Pi. Might be a good starting point. Yeah, there's some good docs. It's really a matter of when I can actually get to it. Oh boy, I'm a little bit behind. Not too far. Circuit assembler. Well, we have an assembler now. Oh no, Paul's order is delayed. Awesome. Okay, let's get to this other question we have. Okay, so David said earlier, or asked me in the chat, time code. Given earlier interest in FPGAs and compared to the focused power of the RP2040s, have you followed the Glasgow Interface Explorer? Is it the next step? Has anyone backed it yet? Just 4 days left on QUAD SPI. So let's pull that up. So I think if you're interested, you should support them. If I remember right, it's an ECP5, and they're well above their goal, which is awesome. Almost 1,000%. That's amazing. I think it's primarily done by forgetting their name. Yeah, but it's the person who does NMeGen. White Quark. White Quark is doing this, I think. And White Quark is amazing. So yeah, Esden's doing it too with White Quark, but I think White Quark's doing a lot of the engineering. So if that sounds cool to you, I highly recommend it. I think for me at this point, I feel like I have too many things. Generally I have too many dev boards. NMeGen's really cool. I would love to get back to it, but the reality is that there's just like a lot I still want to do to make it kind of what I think is coolest. I have these like fantasies of being able to like write a class that represents a peripheral on an FPGA that you can also use as the driver to talk to it. So yeah, it's certainly something to watch. I know that they've done a lot of work on it. I have not backed it. But yeah, it's great to see that they're going that far. I still think if we want to go into FPGAs, I still think the way to go is like having an I2C device that's an FPGA. And in fact, that's what I think I have it on my desk still. Yeah, so this is kind of what I was thinking, and it's my terrible soldering with. Let's change deep dive with Scott to Scott's fantasies. Yeah, the first hour tends to be like this. This is, I think, where I would go with, where I would start, should say, with FPGAs. It's like designed to be a stemma FPGA, so it's a Mach X02. And it's basically like create your own I2C device rather than your whole system on a chip. The goal would be to be like low cost and easy to load. And to some degree, you can think about like how we load software on like a PIO would be something similar as well. But yeah, please, if this Interface Explorer is interesting to you, I can certainly vouch that 1-Bit Squared is a good company to get it from. And White Quark has done amazing work with NMeGen, which is like using Python to define like logic structure, which is, I think, very, very cool. Dave says it's going to complain about pasting another emoji in. All right, we got to that question. That's good. Maybe at the hour mark, we'll switch over here. So Davey asks, does CircuitPython have the ability to toy with clock to get current lower on the new speed? No. I've been trying to be good about like not assuming the clock speed and reading it from somewhere else. But especially for the RP2040, there's not a lot of clock isolation. So no, we've tried to like, what happens when you try to design APIs that work across boards is you really have to simplify them. So like with our sleep state stuff, it's basically like you're on, you're running, you're idle, or if you're in light sleep, like you try to turn off as much as you can. And then if you're in deep sleep, you turn everything off, including like your RAM and stuff. So no, like another way to think about the comparison between Micropython and CircuitPython is like, to some degree, Micropython's designed if you've read the datasheet, and CircuitPython's designed so you don't have to read the datasheet. The consequence of that is that the weird parts of the datasheet you may not be able to do through CircuitPython, where you could potentially do them through Micropython. How is current compared to Portenta? I haven't looked at the Portenta. I have one around here somewhere because I did want to bring CircuitPython to it, but it's just never been a priority. And I've certainly not put it on a power thing. So yeah, can't tell you that. Yeah, Gareth says, if you could provide an I2C stack, that would be a super useful device. So I actually have code. I already wrote the code to load bit streams into the Mach X02 over I2C. I have that. The challenge is like, how do you create those bit streams? I can't remember the name of the repo, but you can bug me on Discord and I can find it later. Ooh, this is a good question. So Mark asked, any part of the RP2040 port that would be useful for me to poke at working on that still needs to be done now that I have a couple picos finally. So what's on my radar is I wanted to redo the flash stuff, which is probably better that I do. UART is a bit tricky because it has like a circular buffer under the hood, but that would be nice. And then I'm working on the audio stuff, which is also pretty tricky. One thing you can actually do though, Mark, that might be a good one for you is parallel bus. So displayio.parallel bus would actually be probably pretty easy. and it would be really, you would use the PIO, but that could be something really cool to do that I think is pretty easy to do as well. So if you wanted to take a look at that, that obviously was not like a top of my list, but there's a lot of these other things that would be really nice. Like Microdev just knocked off the Watchdog stuff too, so the Watchdog stuff works, which is cool too. Yeah, the RTC stuff is not perfect either. Keith E says, I backed the Glasgow, and a couple of years ago I backed the Icebreaker FPGA. For me, it'll be a digital logic analyzer at the very least, so it's a worthwhile tool. Yeah, totally. Johnny was joking that Mark should add Arduino support for the RP2040. Ask Patrick wanted me to point out that Brent has been working on bringing the datetime module from Python to CircuitPython. So you can go to github.com/Adafruit/Adafruit_CircuitPython_datetime now and install that library for datetime on CircuitPython. Foamy Guy points out K-Match did the parallel port work in S2. Yeah, that would be cool. All right, any other questions before we stop with the Scott's Fantasies portion of today and we dive a little bit deeper? I thought it would be really interesting to talk DMA. As I'm doing all this audio stuff, I'm realizing the real beef of the real works in DMA. It's not actually in the audio stuff. NTP. Deermash is working on the Watchdog for this AMD. Yeah, I linked you to the PR from Microdev adding it to the RP2040. Love the Factory says, timecode. Will UART work over old school pins instead of in addition to through the USB? Yes. In fact, it doesn't. The serial connection that you're getting over, USB has nothing to do with UART. Like it doesn't use the UART peripheral at all. It's like the USB version of that protocol. It's unlike something like an ESP32 or an ESP8266, where it's like literally a UART out to another chip that's converting from UART to like USB's version of it. So yeah, it'll work on old school pins. I saw one person get to the point where they were trying to do MIDI with CircuitPython, like actual MIDI, and they needed UART to do that. So we haven't implemented it yet. It's on my list. But I asked Lamore what was her priority, and she said audio. And I think audio is going to be really cool for people. So I'm hoping I can wrap up audio next week. And I'm being ambitious. So what does audio mean in terms of RP2040? We have chance for DMA in the chat as well. Audio. What does audio mean? And I guess this can be a setup for let's dig into this. So I've got a lot of tabs open here. CircuitPython has an audio system. Randy says, where is the parallel PIO bus documented? So what I'm talking about for that is this display IO parallel bus. I don't think I opened an issue for it, but it's one of the ways that you can talk to a display. Is what I was referring to. Bruce accidentally rebooted their computer. Okay, so let's talk audio, and then we'll get into why DMA is like the real thing that you have to worry about. Okay, so if we're looking at the docs, and maybe I should make it a little bit bigger. Let me close this tab. That'll make it bigger. So I'm on the docs, and these are all the modules. We have an audio bus IO. If I click in there, it has I2S out and it has PDM in. So those are two digital sound formats. I2S out is a structure. Actually, I have the Wikipedia open. It requires a separate DAC chip, which does the digital to analog conversion. But the advantage is that those tend to be really pretty high quality sound outputs. Because what you can do is you transmit, you alternate samples between left channel and right channel. And I2S, you can actually vary the number of bits. So like the DAC here, do I have it open? So this is the data sheet for the I2S DAC that we have in the store for Adafruit. And it's a 24-bit DAC. But the way that it works is you transmit from the most significant bit down. So if you only transmit like 8 bits, the top 8 bits are that, and then the rest are 0. So it's super flexible in like how much resolution you on the digital side you give it. So that's really nice. And that's kind of like how you can get high quality audio out of a microcontroller is through I2S. So we have I2S support. The other thing in Audio Bus IO is an input, which is called PDM in. So PDM is pulse density modulation, which means that it's a digital signal in that it's either high or low, but the amount of time that it takes high or low is indicative of kind of like where it is in between. So what you do there is you can like sample it at a particular rate, and then like the number of ones versus the number of zeros can like give you like a perspective on like how like what the actual signal value is, which makes me think maybe I should take one step back and talk about the way that you represent audio. Electromaker points out I2S DACs are way less hassle to use than I expected, to be honest. Yeah, 100%. So let me actually I installed Audacity. Audacity is slow to start up, but it's actually a really good kind of way to understand the way digital audio works. So I think I have, yeah, this is just an MP3 I downloaded. It's just like a chunk of an Adafruit song, so it's totally okay to play. Although I don't think the playback works. Yeah, Audacity is not working that well for me. Yeah, PDM says MEMS microphones. I think they're typically that. So how do I zoom in? So if we zoom, this is, so time is left to right, right? And then the value above or below the line is like, I think of it as like the position of the speaker cone, which I think that is true. So the way that you produce audio is basically you send a stream of values that vary like this over time. And I think if we zoom far enough in, so here's the project rate. So it's 44.1 kilohertz, which means that there's 44,100 samples per second, which actually is quite slow. Oh yeah, there's a better view. So look there, you can see like the individual samples. Davey asks, can CircuitPython support different Ethernet chips or just Wiznet? I think we just have a library for Wiznet, but it's done purely in the library. So if you had another one, you could theoretically write another library, but that's the only one I know of. So this is the challenge with audio. The challenge with audio is that you're basically you're moving, like we talked a little bit about this last week, right? Like computers are number machines. And so the goal of, Electromaker says, I feel like a stuck record whenever I say this, but the folks at Bella have an incredible from scratch audio DSP and C++ course on their YouTube channel. Hop on our Discord and send me a link because I'd love to see that. Discord is adafru.it/discord. I'm not a good DSP person, so I would love to learn more about it. Thank you. Yeah, this will show you my understanding of audio. So the challenge with audio is that you have to continually vary a value, and it's relatively slow rate, right? Like 44.1 kilohertz. This is where I break out my calculator, also known as Python. This is what I like the REPL for, by the way. This is what I use the REPL for. So it's all about how much time you have to do something. So the Pico runs at 125 megahertz. So that's 6 zeros. And then we want to change a value in a register at 44.1 kilohertz, which is 44,100. Which means that we have just under 3,000 cycles of the CPU, the system clock, to move one value to another place, which should be plenty, but potentially, like, I've seen like 320 kilohertz samples and stuff like that too. So generally what CPUs have a problem being consistent, right? This is why the PIO is so interesting. Is that it's something separate. It's not getting interrupted. It's just running at a fixed frequency. So like if this was our PIO, which we can also run at 125 megahertz, like we have 2,800 or so things that we can do. So there's multiple different APIs in CircuitPython. And if we're just talking about like our outputs, we have I2S out, which there's an example for I2S in PIO. So that means that we need to deliver one sample at 44.1 kilohertz, which is kind of the standard because that's what CDs are. And what you can do is you can actually like queue up stuff. So like the PIO has a 4 entry buffer, but if you're only doing one direction, you can use the other one and make it 8. So that gives you some flexibility there. And then let's keep looking through the library. So that's audio bus. We have audio core, which gives us raw sample and wave file. That's how you know like what your sound source is. So raw samples are the easiest. They're just like, I'm gonna, like, when I actually get to testing this, I'll just take this example and try it, right? Like that's the benefit of CircuitPython, is like, this is an example I worked on 3 years ago when I implemented this, and I should be able to just use it. So I'll start with that. Raw samples, they're just in memory, and they're a sequence of values that produce a tone, or you can loop it or whatever. So audio IO is the audio out object, which is if you have a digital to analog converter on the microcontroller itself. SAMD21, SAMD51 have this. The Pico does not. One thing that's also pretty common with a DAC and also ADCs is that they have a particular bit resolution. So wave files tend to be either 8-bit or 16-bit sound samples. I think the highest quality I've seen is like 24-bit, but we don't really deal with 24-bit at this point. But the challenge with audio out is that you get like not fractional bits, but you get like a 10-bit or a 12-bit resolution. So there's some work that has to be done to convert those 16-bit samples down to like a 12-bit sample. And you don't like, one of the challenges is that like a wave file can be really big, and we don't want to load that all into RAM all at once. So there's a system in CircuitPython that basically says like, the thing that's outputting says, hey, give me another chunk of samples. And then it kind of like back propagates and figures out like, okay, like let me get some more samples through this pipeline. So that's audio out. Audiomixer is one of those things that could be in the middle of like a raw sample and the output. this allows you to actually like have both a raw sample and another like wave file and mix them together and then output them. So that's what Audiomixer does. And the MixerVoice is like MixerVoice represents like the like each side of that mixer, I guess. A lot of this is inspired by the Teensy stuff that Paul did, although we don't have like an editor things there. Question from Davey says, should guitar pickups be I2S for a local multi-musician jam session that is synced? I'm not sure. Yeah, I mean, I2S is generally pretty high quality, but I'm really not a great person to ask about the finer details of audio stuff. Audio MP3. So not only can we do raw samples and wave files, but we can actually do MP3 decoding. And I want to try to turn this on. I suspect that the Pico will actually just work with this, but it might vary with quality. So generally that's what can happen with audio, is that like you just have to downgrade the quality of your sound samples to the point where like everything can keep up. Gareth says you need a microcontroller next to the I2S microphones. So maybe MIDI is better. So audio PWM IO. So this is a way to output the audio signals using a PWM signal. So what you can do is you have a fixed like frequency of the PWM, and then you adjust like how high it is for how long, to basically produce the waveform still. This is already used on the NRF52840 because it also doesn't have a digital to analog converter, just like the RP2040. So this is something that we want to do for the RP2040. And I think that's all of the related things. So to summarize, I'm trying to do audio PWM IO. I'm trying to do I2S out, and I thought I'd throw in PWM in, or PDM in as well. Folknology says, can you take advantage of the parallel read/write across memory banks to improve throughput on the Pico? I don't think we need to worry about it because simply like audio is not that fast. Right? Like we did the math versus the system clock and it's like 2,800 cycles. So like I'm not worried about the speed on, I don't think that's our limiting factor. What you do want to be able to do is you want to be able to like not worry about it every time, right? Like you don't want to have to be interrupted every 2,800 instructions just to write another value. And that's where DMA comes in. So DMA is really cool. I think I mentioned it. DMA is short for direct memory access, maybe. But the general idea is that instead of having a CPU have to keep track of like, I'm copying from here to here, DMA, you can say like, hey, copy this much stuff from here to here and let me know when you're done. It's something that like we get some grief in CircuitPython for not being able to do things concurrently. But DMA is something that we take advantage of when we can, and we can do things concurrently as a result. So yeah, DMA is really handy. There are some challenges. Might do that for multi-channel audio. Yeah, it depends on how many channels you want to be able to do. So maybe I'll just pull up my working code. And by working code, I mean code I'm working on, not that it works. So one of the challenges is for PWM-IO. This is the place I started, and I was kind of working my way back. So my plan on PWM-IO is the PWM. I was looking at the NRF52 implementation, and because PWM has a frequency of its own, you want to make sure that the PWM frequency is far higher than what humans can hear. Otherwise, you may actually be able to hear it as part of what you're listening to. So there's some complicated math in the NRF52 side that tries to figure out like the optimal version of that. But it has the challenges that the PWM on the NRF52 is running a lot slower than the one is on the RP2040. So kind of where I've settled is that I can just pick like how fast the PWM is going to be running. So the PWM will always run at the same frequency. And then what we'll do is we'll have, let me pull up the data sheet as well. So here's the problem. Here's my math. So 125 divided by 44.1 kilohertz is great until what you do is you divide it by the number of bits of resolution you want per sample. Because like even here, like 177. So that's still okay. This math is complicated. Let's see if we do 2 to the 10. Oh, 2 times 10. That'll do it. Yeah, I think this is the inverse of the math I was doing. So what you need to be able to do is the way that PWM works, right, is that like it's going to count. So you have 125 megahertz coming in, but then you need n bits of resolution. Davey says, can CircuitPython stream to or from multi-channel I2S microphones or DAC chips at decent audio speeds for music or just voice quality? We haven't really focused on quality. I think you'll find that just because this chip is pretty powerful, we'll be able to do more higher quality stuff than some of our other boards. But it's really just a matter of like how much CPU time we have and stuff. We can only do I2S out right now. We cannot do I2S in yet. So yeah, the challenge with PWM out is that you lose resolution to how long your, like what your top value is of the PWM, which is how many bits of resolution you get in the value. So I think this is going to be the major limiting factor to audio PWM IO, but it's nice that the I2S doesn't have this problem because it's just sending a digital value out. So it costs 2 cycles per bit of resolution. So does it have any DSP that will allow to modify the audio? No. I would love to do a synth IO, but we never did that. I'd love to be able to like generate samples on the fly, but haven't done that yet. So if you're a sound person, there's room to play there. Yeah, so one challenge of the PWM IO is that you can lose resolution. So I think what I'm going to do is I'm going to say, oh, it's just always going to be 10 bits resolution. And there's 2.76 cycles per 44.1 kilohertz sample. So you'll actually output it more than once. David says chiptune coprocessor on the second core. Yeah. Yeah, so the M0s don't have any sort of floating point math hardware. What they did with the RP2040 is that they included some really good floating point software routines in the ROM, which means you can rely on those to be fast access, whereas like code might actually be fetched from Flash, which would make it slower. Okay, so that's a challenge here. So the way that I'm going to have audio PWM IO working is that the PWM will just be clocked at a fixed frequency with a fixed top value. So it won't divide down the 125 at all. What it will do is it'll just divide it by like whatever the top value is. And then what I'm going to do is I'm going to copy in at the sample frequency. I'm going to copy in the value that I want the PWM to be outputting. And there's this really cool feature of the DMA, and it's kind of almost a footnote. Oop, wrong window. It's almost a footnote in the datasheet here, I think. But the DMA on the RP2040 actually has what they call pacing timers. And these are timers that are exclusive to the DMA that can just like output at a given frequency and trigger DMA to copy a value. Yeah, like look at this, pacing timers. It's like three sentences. These allow transfer of data roughly once every n clock cycles instead of using an external peripheral. DREC is a data request to trigger the transfer. So usually what happens with DMA, or the simpler way, is like you have the thing at the edge, like the I2S or whatever, and PIO can do this as well. Like you have it running, and then whenever it has a buffer of one or more, and anytime that there's space in that buffer output, say, like it will raise a data request line, and then you can hook up a DMA channel to pay attention to that. And that's really handy. But I don't think I'm going to do that with PWM out. The PWM will do its thing, and then I'll have a pacing timer that's running at the sample frequency that's basically like copying over at a particular rate. And Folknology says, does that use up a state machine? No, none of this is PIO stuff. At least for PWM IO. Thank you, Bardoctorus, for the link to the Bella stuff. I've heard of Bella before, but I haven't seen their real-time like programming stuff. I should watch that. I'm always looking for good APIs. Let me copy that over. I'll post it here too. Copy link. And I'll put it in the notes too. Somebody didn't grab it already. Oh yes, people wanted the GPIO 15 story too. We can talk about that. Yeah, I mean, not only is it what I know, but it's also what folks who watch know, which is awesome. Okay, so that's my plan for PWM, and there's... I know of at least 3 different ways to do clock division in the RP2040. So the pacing timers, yeah, I figured. The pacing timers have a fractional divider that generates a maximum of 1 request per clock system. So pacing timers can run up to 125 megahertz. The fractional divider is X over Y. And so one thing I did this week that is in my code that is a work in progress is computing. Okay, if I'm taking 125 megahertz and I want 44.1, or however close I can get, like how could I, like what is the ratio, the X and Y that I want to use for that? So what I did is I prototyped a... have it? Oh, I can close this. No, I don't need to save that. In my CircuitPython ports, Raspberry Pi, I did this divisor finder code, and basically what I decided is I could just brute force it to figure out the X and Y of the divisor. So they're each 16-bit values. So I want to do a system clock. I want the sample clock. I keep track of what the best one is. And then I just do a for loop until I find something that's exact or I complete. Um, Davey says, what toolchain choices are there for ingesting APIs to build libraries for CircuitPython? Typically, everything but Extensa, everything but Extensa builds off the ARM GCC. The make files are kind of like a CircuitPython conglomeration of stuff, which is not spectacular, and I want to replace it, and I've talked about that before. And then we don't have the C++ stuff set up, so yeah, we should set it up so C++ can be brought in too, but we just haven't gotten around to it. And I've not done embedded C++, so I didn't really know. Yeah, so here's the trick. So I prototyped this math on here, and I'll show you. So this is me trying to wrap my head around clock rates. And then if I just do Python 3, what did I call it? Divisor finder. You'll see that, oh, here, the numerator is 15, the divisor is 42, 50, 517, which ends up being a 44.100.007 clock rate. This 300 is the remainder, the modulo of something. So this is like, and this is the opposite of that. Yeah, Tim says thumbs up while you're here. I've been happy to see that we're getting lots of thumbs up, which is good. Yeah, so best error, best remainder. And then if we look in my code, and we could, like, you can see I have prints. I was like debugging it. So I first did it the very naive way of like using floating point and all that stuff that Python has, but I actually customized this code after I kind of figured it out to do fixed integer math because I wanted to do that instead. And then let me show you. I haven't tested this yet, so it's all subject to change. But if we go to my branch, RP2040. Yeah, this can get us into audio PWMIO. And don't let me forget about the GP15 stuff. This is going to be bad. I think I'm going to get a unicorn if I compare, because my fork is set to compare against Micropython by default. Oh, it worked. Only 5,000 plus commits different. I think I could do. Adafruit CircuitPython. Main. Hi, Mr. Certainly. All right, this is better. 4 commits. And let me reset the zoom. Haha, Christian says, nice solution. Oh, here's the story about the pacing timer. I almost forgot. I was looking in the docs. I think it's still in there. But this says there are 4 timers available on the RP2040, but I looked in the SDK and it only had 2. So I filed an issue on Pico feedback and I said, hey, like, you need to change this 4 to a 2 because I looked at the SDK and it only has 2. And they got back to me with a response that said, oh, no, the SDK is wrong. We have 4. I was like, perfect. Like, I'd much rather find the errors in the documentation than the silicon has more than I thought. So yeah, I was pretty excited about that. So I'm gonna have to add a system for like sharing pacing timers if like anything else besides audio PWMIO uses them, because they're a resource. But yeah. Gareth asks, how close do you actually need to be to nominal 44.1 kilohertz? Is a few hertz off okay, or do errors accrue? The audio people could probably answer this, but I think like the way that I see it is that it doesn't really matter. Like, if it's a frequency that we can't do exactly, like the closest we get is the closest we get. And what you'll find is that like if you're playing an MP3 that's 3 minutes 30 seconds long, and like if we're clocking it like slightly faster, you'll just find that it like takes a little bit less time and the pitch will be just a little bit off. And yeah, clocking is really fascinating. I was doing audio work. I did a lot of this audio work, I think, for the Circuit Playground Express. And it had an issue. The SAMD21, Christian says, if you're close but not exact, it will desync over time but sound okay. In this case, the more important thing will be the jitter and when the samples get pushed out. Yeah, and David says maybe not a problem if you don't do video and expect it to stay in sync. Yeah, if you want it to be exact, like you could do, I think the 8 kilohertz, like 48 kilohertz divides exactly. I think. So like you could pick a rate that would actually be exact. Now, Cedar Grove says sample frequency may be an issue if moving the samples into a digital workstation. Agree that jitter is the primary concern. Yeah, so I think this is the approach that I'm taking for PWM-IO, or for PWM audio. But we don't need to do that for I2S. Maybe that's not entirely true. So I2S, you'll have, my plan with I2S is that the PIO will clock the data out. So there's a divisor there that you can do, and that divisor is different. That divisor, I think, like I said, I think there's 3 different types of divisors. Like there's this XY one, there's one that's like 8 bits and 4 bits, and then, which I forget what it's for, maybe PWM. And then there's also one for PIO, which is different as well. So yeah, it depends on the divisor how accurate you can get, and then the things that you can get accurate depend on what your source clock is. And then of course your source clock may not be right either. So when I was doing the Circuit Playground Express stuff, what I found is that the way that the SAMD21 works is that it can operate without an external crystal. But the problem is that the internal crystal is really not that great. And in fact, the way that it works well enough to work on USB is that the internal crystal runs, and then you plug it into USB, and it actually synchronizes the internal clock to the USB clock to make it accurate enough for USB. And what I found actually was that on the Circuit Playground Express, originally, what would happen is you could play a tone on the CPX and then plug it in and play that same tone again, but it would be a different tone. Like it was different enough that I could hear it, that it wasn't the same tone, even though the sample it was playing was the same. So yeah, I don't think this is going to have that problem. Like the RP2040 requires you to have an external crystal. And so we should be more reliable from like our source crystal out. But I thought that was a really weird thing with the SAMD21. And the way that I fixed it actually is, I think this code's still in here. On the CPX, I think we only do it for the CPX. But what happens is that if we detect you're on USB, we actually save the calibration registers of the internal oscillator. And then if we have those, we use them again later. To make it so that it doesn't change between off USB and on USB. Yeah, which is interesting. So like, it's one of those things where you have to realize that you're never going to be exact. it's all a matter. It's all a game of like how exact do you need to be. Yeah, very interesting. Okay, so that's my plan for PWM. My plan for I2S is that there's an example that's very straightforward. Let me just find it. Saving the crystal register. Yeah. Okay, we talked about this. Let me close it. We talked about sleep. But that's the philosophy of CircuitPython is we'll do it for you. We'll have APIs for the things you want to do. We talked about basic Python. Talked about Blinka. Pico downloads handy to just have open. I don't have it open. What was I gonna? I just lost my train of thought. Says some high-performance DSP systems use multiple clocks and even jitter reclockers to deal with the jitter problem in I2S clock streams. Yeah, I'm not. There are many levels deeper than I'm able to go here. Paul says much deeper, and you're shaving quartz with a laser. Plan for I2S. Yes. Oh, I was going to bring up the example. Thank you. Raspberry Pi, Pico. So there's two examples directories for Pico. There's Pico examples and there's Pico extras. Oh, and I have it open. It's just not in this one. So here's the PIO for I2S. So it says here, transmit a mono or stereo I2S audio stream as stereo, 16 bits for a sample. You can alter that with the set parameters, or you can program it by using set X with the move X and putting it in the Y register, which this is what I plan on doing, is using the Y register for that. Auto pull must be enabled, and you do 2 samples at once. Data is output at 1 bit per clock. Use a clock divider to adjust frequency. So again, we're going to be at the mercy of the PIO divider to tell us how closely we can get to the sample rate. But we don't actually divide down to the sample rate. We divide down to the 1 bit per clock, which I think is actually 2. I think it's actually 2 clocks per bit. So let's take a look at this PIO. You have to compensate for temperature and gravity for the quartz as well. Okay, so this PIO, and this is the same syntax that we would use for the CircuitPython assembler, which is why I'm glad we did that. The other reason I'm glad we did it, I was watching the Micropython meetup, and the Micropython syntax for PIO does a really bad job at distinguishing instructions from non-instructions, which is bad. Instructions versus non-instruction, because with PIO, it's important to be able to count exactly how many instructions you're doing. And in the Micropython format, it's all function calls, and all the functions look like functions. You can't tell the difference in the form via a label or an instruction. So I'm glad we went this way. Gareth says, so this is PIO pulling from. So yeah, so what the shared bit that we're going to have is we're going to have a ping pong buffer, ping pong DMA. So, and that's the reason I think I can do I2S and PWM at the same time, is we need this same thing. So, what a ping pong thing is that you have 2 DMAs, and they are, what you're doing is you're taking that sample stream and you're splitting it into like odd and even, or every other buffer. So what you basically do is you fill up one buffer and you say, okay, start with that. And then while that buffer is going, you fill in the other one. And then while this one's going, you fill that one in again. And what that means is that you like ping pong between the two. And so like it gives you, if you find something that like it doesn't play well, what you do is you make those buffers larger so that you have more time to fill in the other one while you're at it. So yeah, so what will happen for the PIO or the pacing timer is that it will tell the DMA, hey, I need a new sample. The PIO has its own buffer of 4 or 8 samples. So we'll have some timing slop there as well. Whether we want 4 or 8 is actually up to us. Yeah, that's like the ping pong buffers themselves is not that hard, but the problem is that we have this system where we're like getting the sample buffer from something else, like the mixer, and potentially what we have to do is we have to convert that format of the mixer into the format that we're going to actually produce, or that we actually need to copy things over, which I think is pretty straightforward for the I2S case, but it's going to be more difficult for the PWM because we're going to do like 10-bit. So we actually need to be able to like do some math as we fill in those buffers, and that should be shared. So that's the tricky bit. The tricky bit is the DMA and the keeping the buffers full with the format that they need to output to whatever they're outputting to. So let's just go over this. Folknology says, can we use the SIO in the stream? The SIO is just like writing directly to the IO. I don't think we need to. You don't want to... Sed says, have you got a DMA buffer size limit? Essentially, no. You know, a lot of this system was designed for like a CMD21 where we only have 300 or 32K of RAM. So like the buffers are allocated on the CircuitPython heap. So that depends on, like, that will influence it. And the RP2040 has more RAM. So like you're just going to be able to make those buffers bigger, which would be really helpful. The DMA on the RP2040 has the ability to do ring as well, which basically means that like it can automatically start again at the start of a buffer, but it's very limited in that the ring... Where do they talk about this? I've spent a lot of this week reading this chapter on DMA. It's based on... you have to have, if you do a ring, it has to be a power of 2 and it has to be aligned with the power of 2, because basically what it does is it just masks like the lower however many bits you have, and I don't think it necessarily like tells you when it's complete either. It's something I was thinking about using for UART as well, but I'm not planning on doing that. What you can do instead for the ping pong stuff is that you can chain. So you can chain from one channel to another. Yay, Mark! Mark built CircuitPython for the RP2040. Yeah, it should be really easy. It's not like the IDF. It's simpler than that. So I think the way that the chain 2 stuff works, and I haven't actually gotten this testing, but basically what you can say is like, you can set up one transaction per channel. So you can tell, if we just look at like, what do you need to know for a DMA transfer? Let's talk about that first. So it's a little small, but I think the quality should be good enough. If you make your screen big, you should see it. So there's basically like the read address. So this is where you're copying from. The write address, which is where you're copying to, and then transaction count. So that's how many times you're going to do those copies. It's not in terms of bytes, because there's also this fourth register, this control register, that has a lot of knobs that you can do. And maybe we're diving deep. Let's talk about all this. Yay, Lucas got their Pico. That's super exciting. So there's lots of things there, but the list of registers is actually kind of handy too. So let's just look at that. There's the read address, the write address, and the transaction count. That's not the number of bytes because you can change the data size. So if we look at this control register, we can see there's 3 bits for error status. Mike got theirs too. Awesome. The Picos are really cool. Like the RP2040s are really cool. So busy flag, this tells you whether it started and it's in the process, like it's counting down transactions. Sniffer enable, this is something that some DMAs have. DMAs actually have the ability to do like a CRC computation on the data it's copying. And that's really useful if you're worried about data being corrupted, is that you can use DMA, say like, hey, figure out a CRC for this data. And you could actually you could probably copy to the same place and CRC it, which would be cool. So you can do DMA can copy from memory to memory, memory to peripheral, or from a peripheral to memory. So that's pretty neat. You can swap bytes. You can change the way that the interrupts work. So T-Rex select, transfer request select, and this is either the data requests that we talked about, which are from peripherals, or you can see the 4 timers are here as well. And then 3F is a permanent request. It just does it as fast as it can. So chain 2 is the thing that allows you to automatically switch from one buffer to another. There's that way to do it, and then there's other ways to do it. So the way that I'm thinking I'm going to use chain 2 is that I have to allocate 2 channels. So there's 12 total DMA channels. So that will be a limiting factor. And then the number of pacing timers, if we're doing PWM audio, will be a limiting factor as well, because there's 4. So we'll have to have 2 DMA channels, one for buffer A and one for buffer B. And then this chain 2, you chain this DMA's channel to the other one, so that when you finish this transaction, it automatically keeps going. And that's the moment that you have something that's like, oh, I got to fill this one up now, before it gets to the end of this buffer and returns back. So that's one thing chain 2 can do. The other thing that chain 2 can do, which I don't think I need it here, but what you could actually do is you can actually have chain 2 as a meta, almost a meta DMA. So instead of DMAing memory to peripheral, what you could do is you could actually do memory. So you finish your buffer, you trigger another DMA, and that DMA is actually writing to the DMA peripheral to change the buffer that first channel DMAs to, changes the settings of that first thing. So if you wanted to chain 5 buffers together that were all separate pieces of memory, you would actually be you would have this meta DMA that's updating the configuration of the first one when the first one finishes, which is kind of just mind blowing. And the reason I didn't want to do that is I only needed the 2, so I can just have the 2 chaining to each other. But if you wanted more than 2, then you could do this meta sort of thing instead. It will be a little slower to react, because you may, depending on how many registers you have to overwrite in that first DMA's config. But yeah, it's pretty wild. So here's the ring stuff, whether you want to treat it as a ring or not. One thing that's very handy and a lot of DMAs have is increment write and increment read. This is really handy if you're writing or reading to the same register over and over again. So this is really common if you're going to or from a peripheral, right? There's one register for adding to the FIFO for the PIO. So if you're writing to that, you're always going to write to the same address. You don't need to increment for every transaction. Data size. So you have the option of like transferring a byte, 2 bytes, or 4 bytes. And it will change if you are incrementing either the write or the read addresses. Like it will increment them based on that number. Then high priority, and then enable. And I'm actually putting on. So another wrinkle that I've had to think about for the audio stuff is that our APIs allow you to pause and resume. And if you pause audio, you basically want to keep the same value that you were using. If you don't keep the same value, you're going to inadvertently cause like sound. So that's another wrinkle in the whole thing, is figuring out how to pause and resume. I think for the PWM side, it's very easy because like we have PWM running pretty independent to a pacing timer. So if we just disable DMA, the PWM is just going to stay the same. Good night, Randy. Thanks for hanging out with us. See you next week, hopefully. Yeah, so that's pretty wild. So DMA is super duper powerful. It's a way to do lots of data stuff without the CPU's involvement. Tim says, yeah, inadvertently causing sound is unpopular with your users. Yeah, if you've ever had like your headphones go like or something, like it's tricky. Gareth says I2S not so easy to pause. Yeah, totally. I was looking at the way that Jeff did it for the I2S on the NRF. And basically, I think what you have to do is you have to DMA. What you could do is you figure out what value you're on. You stop the DMA, and then you just like set up a new DMA that's like copying that value over and over and over again. Until you resume, and then you have to figure out how to get back to where you were. So, yeah, it's going to be tricky. We'll see how well we can do. But yeah, it's not as easy as the PWM side. Yeah, Tim says we're wired to notice sound glitches even faster than visual glitches. Hi, Paul. Thanks for dropping in. You have inspired like a lot of the way that I did this audio work. Although I'm sure you would have done it better than I would have. Aspiring to match the teensy audio stuff. Seth says, typically wouldn't you just pump out zeros and smoothly mute in and out what's coming from the mixer? We don't always have a mixer. But yeah, we could. That's the other thing. Zero is not always zero. Because in I2S land, it's signed, but for PWM and DAX, typically it's unsigned. So there's like sign conversion that you have to worry about as well. Gareth says, how to choose when you have 3 ways to implement it. Good question. Sometimes the first way you do it's the best. If that doesn't work, then you change it later. Paul says, from experience, that won't give you the pause behavior you want. If you want to go from sound to silence, you need to make a gradual transition over several milliseconds. 100%. Eric says, fade to 0 works too. Just let the DMA buffer run on null data. Yeah, but you have to fade it first. Yeah, maybe the buffer filler just fades it. We're not spectacular about it. If you're an audio person and you care about this stuff and you want to work in C code, like we have places you could help us for sure. Like there's a to-do in the NRF that says like when you start up, ramp to the like, we allow you to specify like a quiescent value, which is like the value that you kind of want us to like start and stop at. But there's a to-do in there that says like ramp to this value. We don't right now. So yeah, if you're really into audio stuff, Paul's teensy library is really good. I did actually look at potentially bringing the teensy audio library into CircuitPython, but there was a lot of stuff that was statically allocated at compile time. And like Arduino has the benefit that the compiler can do a lot of optimization, whereas CircuitPython can't do that. Okay, I think that's the brain dump of all this audio work. It's not a trivial amount of work, so I'm hoping to finish it tomorrow. Where's that? Where's Paul's library? Teensy audio. I think that's what you're talking about. Alvaro points out there's an old entry in jobs.adafruit.com for Adafruit asking for people who know about filters. Can't remember if it was audio was the context. I think it was. So PDM microphones are 1-bit samples, and you have to filter them to get higher bit resolutions. And like, my brain doesn't work well for it. Yeah, so that was part of the reason, is like audio is really tough. I think this is the right link for the teensy audio stuff. Yeah, let's do some questions. Let's do some questions, and then we'll call it a day. I'll get back to this audio stuff next week, but it's Friday afternoon / evening. If you want to, I showed my branch if you do want to take a look at it. And no, I didn't talk about GPU 15, so let's talk about that. But let's handle any questions that have come up here. Okay, we did that. Let me do questions first, because they're scrolled off. I have GPIO 15 in my list already. Johnny says, nah, it's way after midnight. Okay, completely unrelated question. Is there a way to use the USB connection as a USB CDC serial device with Micropython? I would assume since the REPL is over the USB, this wouldn't work. So in CircuitPython and Micropython, the CDC connection is used kind of for the core. And there is ways that you can get data to and from, but the problem is that the core does look for certain values, like Control-C, and like immediately follows them. So there's no good way. Dan is about to start working on in CircuitPython having a second CDC connection that is like dedicated to the user, which won't have that problem. So the way that you can do it now is what you can do is you can use print to have out over serial, and you can do input in Python to read from serial. But yeah, it's not spectacular, because there is some stuff that that you can't do. Okay. Paul says the thing about audio is that for every successful feature you implement, you get requests and learn about 2 more to do. 100%. I see all the GP15 stuff. Thank you for reminding me. Let me answer this other question that's not copied in yet. I will get to it. Everybody wants to know what the deal is. But Badar says, what are the downsides of the RP2040 compared to Sandy 51? Oh, and let me snag this one too from Folknology. So one thing that the RP2040 that doesn't do that the Sandy 51 does is the Sandy 51 is a Cortex M04 with floating point. So if you're doing a lot of floating point math, the Cortex M0 or the Cortex M4 and the Sandy 51 is going to be better. If you're, USB is better. You have comparable RAM, like the top parts of the Sandy 51 have 256K RAM as well. It has built-in flash. So with the RP2040, you have to have external flash, which is not, it has benefits. It has benefits in that like you can have a lot. The downside is that if you have to go there, it's slow. So if your code doesn't fit within like a 16 kilobyte cache, which is what they have on the RP2040, you're going to be a lot slower than you think you are. They both have DMA. They both have a lot of peripherals. The SAMD51 does have a digital to analog converter, so if you want to go to like analog values, that's better. But the PIOs are really cool. So if you're doing any sort of digital interfacing, the PIOs are going to be really neat. The SAMD51 has this thing called the CCL, which is like 8 lookup tables full of logic. So if you do need to do like very basic, like take this pin and AND it with another pin, you can do that. But it's like leagues dumber than the PIOs are. SAMD51 has more pins. If you need a lot of pins, the SAMD51 has more. Like the RP2040 only has 30 GPIO. Yeah, I think that's kind of what I can think of. I think the RP2040 is going to be cheaper, if that matters to you. But yeah, it's all trade-offs. I think the RP2040 is very clearly designed to be a complement to what you get from a Raspberry Pi, meaning that it's like very good at being very real time. And the SAMD51, like I said this in the hack chat, is like I've tried to be very real time with it by talking to a Game Boy, and I just didn't feel like I could do it that well. Yeah, Paul says M4 is so much faster per clock cycle. Yeah, M4s are just like they're significantly faster than M0s. But of course, you have 2 M0s on the RP2040. We don't use that in CircuitPython, but you could do it. Badar says, "Oh yeah, I heard Lamore say about the lack of analog input. So both have analog inputs. The RP2040 only has 4 of them, but the SAMD51 has more, and then the SAMD51 has digital analog outputs, but the RP2040 does not. The RP2040 does not also have a touch peripheral, which the SAMD51 and 21 does as well. So yeah, it's interesting, right? It all depends on what you're doing and what you need to be able to do. Relatedly, Mike says, do you think the Raspberry Pi 5 will have the RP2040 as a coprocessor? I fully expect that. I have no insight into whatever Raspberry Pi 5 will be, but that makes total sense to me, right? Like, if you talk about the things that the Raspberry Pi does not do well, like having the RP2040 as a coprocessor solves some of those problems, like analog input. Like, it makes total sense. Like, I would be very surprised if they did not. Davey, sorry, I'm going a little out of order. Davey Baker says, can you be a web server in CircuitPython? Yes. It's very, very new code, and it is changing still. But we just added to Lucian, just added the bind, accept, and there's 3 socket APIs you need to be able to be a web server, and he added them. So on the ESP32S2, you can accept TCP connections, which is what you need to do that. So barely. It's not going to perform anywhere near what a Raspberry Pi would. Let's see. It's not done, but it does. I think some people have worked. It's being redone a little bit. There's a PR out to reorganize some stuff, but it is in there. It's in beta 1, I think. Folknology said, could you inject ramp PIO instructions for the transition? I suppose you could. I don't know how many instructions it would take, but you could certainly like Like it does allow you to do like very basic like increment decrement stuff. Uh, listen, thank you, Anecdata. Okay, let's talk GP15. And if there's more questions, we'll talk. We're out of time, but I don't have to immediately go. Okay, so GP15. This is something that we ran into where GP15 is this pin that is broken out on the Pico and in fact is used in a lot of examples in the Micropython book. But only a week or two before the launch, I heard this thing from Lamore that said we can't use GP15. Like there's this silicon bug in the USB that uses GP15, so like it's just a no-go. Like you can't use it, blah blah blah. And I was like, all right, well, I like removed GP15 even from the like internal like microcontroller.pin, and then I was like, you know, I should probably have it in there, but I won't put it in board because we can't use it. And then launch happens, and we've discovered like the day before Kattni's doing this guide to like go along with the book. It's like, oh, all of their examples use GP15, even though like our understanding is that you shouldn't. And so we're like, all right, well, like we'll take it, like we'll add it back. And we did some investigation, and like I asked the Raspberry Pi people, I was like, so what's the deal? Should we use this or should we not use it? And if you look in the data sheet, you can actually see the errata are at the bottom. So if you just go to the bottom, I think it's E5. So like the USB device fails to exit reset state on the busy USB bus. And then the workaround is like there's some debug logic for the USB that's connected to GPIO 15. And basically for like just under a millisecond, like it takes it over and pretends to the internal circuitry to reset. But the problem is that like if you're using GP15, like it just overrode whatever you're doing with it. Not forever, but whenever you need to do a reset, then it's required. So I'm a little bit like, I don't like to make it. I don't like to take things fast and loose. So like I was hoping not to like expose it at all, but like it was just found too late in the process, and so we've added it back, and you can use it. And there's this chance that like if you need to reset your USB bus, like it will take over the pin and like not quite like put it back to its own state. CircuitPython is probably not a big deal because CircuitPython, when you connect to USB, will likely rerun your code, and when it reruns your code, it will reset the state of that pin, and then it'll work again. So it's not like super fatal. But yeah, it's kind of a pain. And so it's enabled. I assume they'll fix it whenever they do a rev of the silicon. I don't know when that's going to be. But for now, I guess we're just all playing it a little fast and loose. And you can choose to like not have it there or not, on or not, like the fix for it. But I think the case is like your USB never comes up if your USB bus next to it is really busy, because the like peripheral expected to see a long delay, but like if the bus is busy, it's actually seeing a lot of traffic. So yeah, I think that's the story for GP15. Did that answer? I don't know who originally asked about it, but we should have it now. Yeah. Okay, I think we got one more question, which I think was answered in the chat already. Which is, oh, that's not where my notes are. What is the best target for CircuitPython to do Ethernet? As far as I know, Ethernet is only done through the Wiznet right now. We did previously have like native Wiznet stuff, but that is being deprecated because I don't want to do it that way. I want all our networking stuff to live in the VM because we have so many coprocessors that do networking. So yeah, that's later said. Yeah, we have to call it too. It's been a while. But yeah, I know of the Wiznet. If folks want to do the other stuff, then that would be awesome. But yeah, thanks, Electromaker. Take care. All right, let's wrap up. One final time code. Thank you all so much for hanging out with me. I know that these streams are long, but we spent the first hour answering a bunch of questions. Let's see. Oh yeah, this timer is ahead of even my time here. As always, this is a deep dive. It's this deep, this long every week. Fridays at 2 p.m. Pacific here on the Adafruit streams. If you want to hang out with me and others and have questions in the interim, you can go to the Adafruit Discord server. People will love to help you out there. You can go to the URL adafru.it/discord to check that out and get some help. We do CircuitPython development there. We answer questions there. I recommend it. We have Discord for the chat here as well. Next week, we'll be on Friday again. If you want to support me, support Adafruit by going to adafruit.com. Purchase some hardware there. I think we've sold a lot of Picos, which is great, really helpful. And we'll have some board designs of our own once we have the chips in hand. And I don't have a housekeeping list at the end. But yeah, in a couple hours, I'll have all the notes and the time codes in the description as well. But for now, thank you all. We'll see you next week and see you on the Discord in the meantime. If you have a Pico and haven't tried CircuitPython, please do. I think you'll be very pleasantly surprised. And if you know people who haven't tried it, also ask them as well. You can go to circuitpython.org/downloads, search for Pico, and you'll see it there in the list. Works for 100 and some odd boards as well. Let's see, what is our count? 173 boards. So we'll probably bake 200 when the RP2040 chips are available. Anyway, thank you all, and I'll talk to you next week. Cat cam. Kitty. All right, good night, everyone.